Volcanoes, geysers, and hot springs. Oh, my. Our planet can be a steamy one, and all that heat has got to go somewhere, right? But did you know that Earth's natural heat could also power our homes and even drive our cars? That's just one example of how humans are learning to harness the Earth's fury with modern technology. In this series, we explore how civil engineers use science and math to design, build, and maintain the structures that help us get by. And today, we're looking at geothermal energy. Let's dive in. What is geothermal energy? Simply put, geothermal energy is the heat generated within the Earth's core. There are three main sources of this heat. The first is the leftover heat from when the Earth formed 4.5 billion years ago. The second is the energy generated from the decay of radioactive elements in the Earth's crust and mantle, which is the layer between the Earth's core and its surface. And finally, the third source is the heat we receive from the sun that's absorbed by the Earth's surface and then radiates into the subsurface. But how do we take this heat and turn it into energy we can use? Well, start with the basics of geothermal power. There are two types of geothermal systems based on where they get their heat. The first type is a hydrothermal system, which uses water that's heated by the Earth's internal heat. These systems are pretty common, and they're what's behind many of the hot springs and geysers you might have seen around the world. In fact, if you want to see an awesome display of geothermal energy, check out Yellowstone National Park. Most of its famous features, like the Old Faithful geyser, are powered by geothermal energy. The second type of geothermal system is called an enhanced geothermal system, which uses dry steam or hot water vapor to generate electricity. Enhanced geothermal systems aren't as common as hydrothermal systems, but they're still pretty widespread. For example, the Geysers in California is the largest geothermal power plant in the world, and it uses an enhanced geothermal system to generate electricity. So how exactly does geothermal power work? Let's take a look at the most common type of geothermal power plant, the dry steam power plant. Dry steam power plants use steam that's extracted directly from the Earth's subsurface. The steam is then used to drive turbines that generate electricity. It's pretty simple, really. The only real challenge is getting the steam to the surface without losing too much pressure. If the pressure drops too much, the steam condenses into water, and the power plant won't be able to generate enough electricity to be cost-effective. To prevent this, engineers use special drilling techniques to keep the pressure high enough to drive the turbines. Another type of geothermal power plant is the flash power plant. Flash power plants use hot water that's pumped to the surface from deep underground. The water is then flashed into steam, which drives the turbines. This type of power plant is a bit more complex than a dry steam power plant because you have to deal with the water turning into steam. But it's also more efficient because you can use lower temperature water. Now, while geothermal energy is a great way to generate electricity, there are some challenges associated with it. For one, geothermal power plants produce carbon dioxide and other greenhouse gases. However, these emissions are typically much lower than those of fossil fuel power plants. Plus, geothermal energy is a renewable resource, so the overall impact on the environment is less than that of fossil fuels. Another challenge is that geothermal power plants are expensive to build, because you have to drill deep wells and install complex equipment. But the cost of geothermal power is coming down as technology improves and more plants are built. Geothermal energy isn't just for generating electricity, though. It can also be used for direct heating and cooling. Geothermal heat pumps use the relatively constant temperature of the Earth's subsurface to heat and cool buildings. They're pretty simple devices. They consist of a heat pump that absorbs heat from the ground and a series of pipes that circulate fluid through the building. The fluid absorbs heat from the building when it needs to be cooled and releases heat into the building when it needs to be heated. Geothermal heat pumps are very efficient, which makes them a great option for heating and cooling buildings. They're also environmentally friendly because they don't produce greenhouse gases. So now you know the basics of geothermal power. But how is it used in the real world? Let's take a look at a few examples of how geothermal energy is being used to power our lives. Harnessing the heat. One of the most promising applications of geothermal energy is in the area of direct use heating and cooling. As we mentioned earlier, geothermal heat pumps can be used to heat and cool buildings very efficiently. In fact, geothermal heat pumps are up to 5 times more efficient than traditional air conditioning and heating systems. So they could help us save a lot of money on our utility bills. Plus, they're environmentally friendly, which is a major plus. Some companies are even experimenting with using geothermal energy to heat greenhouses, which could lead to more efficient and sustainable agriculture. Imagine fresh vegetables year-round without the need for artificial heating. Pretty neat, huh? Going green with geothermal electricity. Geothermal energy can also be used to generate electricity. In fact, it's already being used in several countries, including Iceland, which gets about 25% of its electricity from geothermal sources. In the US, geothermal energy accounts for about 5% of electricity generation. And with new technologies, geothermal power is becoming more efficient and cost-effective. Plus, it's much cleaner than coal or natural gas, which means it could help us reduce our carbon footprint. Driving on the heat. Who says we can't use geothermal energy to power our cars? That's right. There are companies working on developing geothermal-powered vehicles that could be the future of transportation. The idea is to use the Earth's heat to generate electricity that would power electric motors instead of internal combustion engines. It's still early in the game, but if it works, it could revolutionize the way we power our cars. Imagine filling up your car with electricity from the Earth's heat. Now, that's a game changer. The future of the geothermal energy. Now that you know just how versatile geothermal energy is, you're probably wondering what the future holds for this exciting field. Well, experts believe that geothermal energy could play a major role in helping us meet our growing energy needs while reducing our reliance on fossil fuels. New technologies are making it easier and cheaper to harness the Earth's heat, which means we could see more geothermal power plants and other geothermal energy systems popping up in the years to come. Geothermal energy is a clean, renewable resource that's available 24/7. It's not affected by weather or time of day, so it can provide a reliable source of energy. Plus, it has a very small environmental impact compared to other energy sources. Of course, there are still some challenges to overcome. Geothermal energy is not available in all locations, and it can be expensive to drill the deep wells needed to access it. But as technology advances and costs come down, geothermal energy is poised to play an increasingly important role in our energy mix. So keep an eye on this exciting field, because who knows what innovations are just around the corner. As you can see, geothermal energy has a lot of potential, but it's not without its challenges. But as technology improves, geothermal power is becoming more efficient and cost-effective. Who knows? Maybe one day we'll be powering our entire cities with the Earth's heat. Until then, though, we'll just have to enjoy the view from Yellowstone and dream of a hotter tomorrow. Thanks for watching. If you like this video, hit that thumbs up button and let us know in the comments below what you think of geothermal energy. And don't forget to subscribe so you never miss an exciting episode of Civil Engineering Explained. See you next time.